Hi, my name is Arjun from CSC Cybersecurity branch. Today I am going to discuss about single mode and multi-mode optical fibers. What is an optical fiber? An optical fiber is a hair thin cylindrical fiber of a glass or any transparent dielectric medium. The fiber which are used for optical communication are waveguides made up of transparent dielectrics. Its functions is to guide visible and infrared light over a long distance. Structure of optical fiber. Actually, you can see here the structure of optical fiber, which consists of core, coating, outer jacket, strength member, and cladding. Types of fibers. Single mode cable. Single mode fiber. Single path through a fiber is a single strand. Most applications use two fibers of a glass fiber with a diameter of 8.3 to 10 microns that have one mode of transmission. Single modem fiber is used in many applications where data is sent at multi-frequency, that is wave division multiplexing. So only one cable is needed. Single mode on one single fiber. Single mode fiber gives you a higher transmission rate and up to 50 times more distance than multi-mode, but it also costs more. Actually, you can see in the diagram, single mode fiber has a much smaller core than multi-mode. It has a narrow core which is of 8 microns or less than that, and the index of refraction between the core and the cladding changes less than it does for multi-mode fibers. Light thus travels parallel to axis, creating little pearls and depression. Telephone and cable communication networks install millions of kilometers of the fiber every year. Next, multimode fiber. What is multimode fiber? In multimode fiber technology, optical fiber technology, multimode fiber is an optical fiber that is designed to carry multiple light rays or modes concurrently, each at a slightly different reflection angle within the optical fiber core. Multimode fiber transmission is used for relatively short distances because the mode tend to dispense over long lengths. This is called modal dispersion. Such as within a building or on a campus, typical multi-mode links have data rates of 10 MB or 10 GB over link lengths of up to 600 meters, that is 2000 feet. For longer distance, single mode fiber, sometimes called as monomode fiber, is used. Multi-mode fiber is usually 50 by 125 and 62.5 to 125 in construction. This means that the core to cladding diameter ratio to 50 microns to 125 microns and 62.5 microns to 125 microns. Step index multi-mode fiber has a large core up to 100 microns in diameter. As a result, some of the light rays that make up the digital pulse may travel a direct route, whereas others zigzag as they bounce off the cladding. This type of fiber is best suited for transmission over short distances. Graded index multi-mode fiber contains a core in which the refractive index diminishes gradually from the center axis out toward the cladding. The higher refractive index at the center makes the light rays moving down the axis advance more slowly than those near the cladding. This type of fiber is best suited for local area networks. Advantages. Advantages of optical fibers, which are single mode and multi-mode, are multi-user framework, high power signal transmission capacity, real-time data transmission, high bandwidth and transfer rate, high security, support of multiple protocols. Multi-mode cables are less expensive to operate, install, and maintain than single mode cables. Disadvantages are more limited in both speed and distance. As the number of modes increases, the effect of modal dispersion increases. As you can see in the diagram, multi-mode, and a single mode. The conclusion: multi-mode fiber is an optical fiber that is designed to carry multiple light rays or modes concurrently, each at slightly different reflection angle within the optical core fiber core. There are two categories of multimode fiber, namely step index multimode fiber, graded index multimode fiber. Multimode optical fiber generally used for backbone applications in the building. They have both advantages and disadvantages of multi multimode fiber. Actually, here multimode fiber is a transmission which is used for relatively short distances because the mode tend to disperse over longer lengths. This is called modal dispersion. Such as within a building or a campus, typical multimode links have data rates of 10 MB to 10 GB over link lengths of up to 600 meters, that is 2000 feet. For the longer distance, single mode fiber is also used. As actually you can see in the diagram, we have so many parts. Those are outer jacket, coating, core, cladding, strength member. uh, and here single mode fiber gives you higher transmission rate and up to 50 times more distance than the multi mode, but it also costs more compared to the single mode. Single mode fiber has narrow core, 8 microns or less, and the index of refraction between the core and cladding changes less than it does for multi-mode fibers. Telephone and cable television networks install millions of kilometers and fiber for every year. Next, grad index multi-module fiber. This is very important. Contains a core in which the refractive index diminishes gradually from the center axis out toward the cladding. The higher refractive index at the center makes the light rays moving down the axis advance more slowly than those near the cladding. This type of fiber is best suited for local area network. And coming to the conclusion, multimode fiber is an optical fiber that is designed to carry multiple light rays or modes concurrently, each at a slightly different reflection angle within the optical fiber core. There are two categories of multimode fiber, namely step index and multimode fiber and graded index multimode fiber. Multimode optical fiber generally is used for backbone applications in buildings. These have both advantages and disadvantages. As already we have read advantages and disadvantages. Mostly these are the high advantage for high security, and disadvantage as the number of mods increases, the effect of mod dispersion also increases. These are the advantages and disadvantages. Thank you for giving this opportunity.